So today we will discuss about what exactly the linked list is and how we can have our own implementation of linked list. Okay. So first of all, we will understand what is a linked list. If you see, a linked list is a linear data structure in which the elements are not stored at contiguous memory locations. Okay. So eventually linked list is the part of data structure where it will not be stored contiguously, means one beside the another. So we will see what exactly the contiguous memory allocation is. In a simple word, a linked list consists of nodes where each node contains a data field and a reference link to the next node in the list. Okay, means it is like, we will have the node and each node will be connected with each other. So this exactly is what we have in the linked list. So if you see, like it says, a linked list is a linear data structure. Obviously, what is a linear and non-linear data structure? So if you see, linear and non-linear data structure has been explained with the help of this diagram, where if you see, linear is in the sense we can say, in a linear data structure we traverse through elements sequentially, means one node will be connected with the next node and so on. So this is what the linear data structure is. And on the other hand, if you see the non-linear data structure, so here we have, in non-linear data structure, one node might be connected to several other node. Okay, there is no only one way move forward, like one way or sequential execution will not be there. In this case here, in a non-linear data structure, you can see on the top, this is like tree like a structure where there is no guarantee, but one node might be connected with multiple node, that you can see, like the node that we have on the top is connected with three node, and again like he one on the right is connected with two nodes. So this like if every node is connected with the one node only, in that case we can say the linear data structure. And if one node is connected with multiple, or more than one node, in that case we can say non-linear data structure. In a non-linear data structure we can take the example of a tree, okay, where there might be the two or more than two root of a tree. So now, what is contiguous memory allocation? If you see in the first one, we have this, assume this is a memory where, like, in we can take the example of array, where array needs a contiguous block of memory. That is, if we create an array, what happens, like, suppose we created the size for 6, you can say. So in that case, each block will be sitting just beside the one, okay, and that we can access directly with index. But in this one, where memory allocation will not be contiguous, you can see, like, in a basically linked list, memory allocation is not contiguous. So you see, the suppose every red block is the node, so one node is here, another node is here, and like this, means there is no a particular pattern. But in linked list, what will happen, the node will be created anywhere wherever the space will be available, there object a node will be allocated, but the previous node will be pointing to the next node. This is how basically happens. So if we consider this as the first node, it will be pointing to the next, then it will point to the next, and so on. So every node will be connected with the next node. This way basically linked list works, and this is what basically the linked list looks like. So now if you see, here is the diagram which represents how our linked list looks like. Okay, so here we will have the one header which will always be pointing to the very first element. And now you can consider in this everything is node over here. So a should be treated as a part of data, and here the next section represent key address. This will be containing the address of the next node. Then again, b section is the data section, and this empty section is the something which will be holding the address of the next object. So like this basically we have, and eventually the last one will be containing the address of null, indicates it is not pointing to any other node, and that is the last node of the linked list. This way we have a we can say linked list is. So we have circular linked list also. So difference is like, in circular linked list, the last node which here is showing null, but in circular the last one node will be pointing to the a node, first node. So this way basically it works. So here currently we are having the example of singly linked list, where each node will be connected with the next node only. Now here we will see the implementation of linked list here. you know in fact, basically the linked list is nothing but is a part of collection, and we have inbuilt linked list classes. We can create the object of linked list and we can start using that. But here we will be creating our own linked list. Okay, so what we can do, you can see in this diagram, like this is the linked list class. For the sake of simplicity, we have already created this code. So we will try to understand here what we are doing. Like we have created our own linked list class. Okay, and we have tried to resemble the one that comes with the inbuilt. Okay, so this linked list will also be having all the functionality. We'll try to create those functionality which is also available in the linked list class, which comes with inbuilt classes. Okay, so this linked list we have created, and here what we have done inside this, we have one node type header which will always be pointing to the first node. Okay, then we have the add method which will be responsible to add. So one by one we will trace the code and we'll see how exactly it works. So if you see, this is our class program, and guys, a console application always starts their execution from main method. So we will put breakpoint here and we will execute the code in debug mode. Along with that, I will also try to draw the diagram so that it will be more helpful and we can understand it. So now I will run the code, and we will try to understand how have we implemented our on linked list rather than using the inbuilt linked list classes. So here what we are doing, we are creating the object of linked list. Okay, if you see, basically one object of linked list will get created at this point. So in here in the paint I will draw the diagram also. So assume this is the linked list class. Okay, and if you see in this one, so on this one what will happen, like all the member present inside this linked list will get allocated in that object. So non-static member, basically we know a static member is not created inside the object. So this head will be created, and we don't have any constructor. So by default default constructor will be executed, and in this head the default value, since this head is of node type, so this is a non-primitive data type, so they will have their default value null that will be assigned to head. So one head will be created inside this object. So we can write here head, and we are not initializing anything, so they will have null as the default value present in this object which we are creating from program.cs. And once the object gets created, their address will be assigned into this list reference variable. So we will take, for example, suppose this is the object we can name it a, and this got created at memory address 1000. So assume this is a random address we are taking. So 1000 is the address. So what will happen after getting created this object, or we can also say this is actually linked. Okay, I will write here. This is actually linked list object. Linked list I wrote, and then once object gets created, their address will be assigned to this list reference variable. So here we can write somewhere else like list equal to 1000. This is the reference variable. Since this list reference variable is holding the address of a object, so we can also draw diagram like this for our understanding purpose. Means we can say that this list reference variable is pointing to a object, and in this a object there is only one data member, that is nothing but a head, and we have not initialized this head anywhere. So inside this the default value, that is nothing but null, will be there. This is what basically will happen when this line will be executed. Now we are seeing list dot add method. So the object which is being pointed by this list, on that object add method will be called with value 56. Let's trace that also. So I will press F11 and we came here. So now if you see, data is set to 56. Okay, and inside this we are again creating one object, new node means one object of type node will be created. If I press F11, this is the object, this is the class whose object will be created, and from the constructor we are initializing this data. So what will happen, basically when this constructor will execute, so two member data as well as next, these two data members will be created in this object, and whatever the data that we pass, that was 56, will be assigned to this data. But again if you see, this next has not initialized, so I believe you might have understood, this next will remain in their default value, that is you can see here null. So this null will be the value. So again, one more object will be created here, something like this. We can name it b object, maybe the name we are giving for our understanding purpose. This will not be happen, name will not be given, but definitely one object will be created in the memory. And then let's assume they will have some address also, so we can say 2000 is the address that assigned to this, and this object has two data. Okay, two data member. First one is a data, and the data will have the value 56 that you saw, like that was initialized from here. Basically using this variable we are accessing the global variable, this object variable data. So inside this we are initializing the value of this data, that is nothing but 56. But next is still in their default state, because we are never initializing the value of next. So next will have the value null only. So next will have the null, and we are done now. So once this object gets created, what happens, like this is the code you can see, like with new keyword we are calling the constructor with value 56. So object got created, and when object got created, it will return address of the object, and that address basically will be given by the operating system. Okay, so that could be any random values, but currently for our example we have taken this 2000 as the memory address. Okay, so this 2000 will be stored inside this node reference variable. Okay, so now this node will have the value 2000. So we can create this node anywhere, and inside this we will store the value 2000. So this is how basically will happen in memory, but for our understanding purpose we will draw the arrow also, just to indicate like this time this node is pointing to b object. Okay, so that's it. This is what basically will be happening in the background in the memory when this line will be executing. Once this line gets executed, now it will execute the if block. Okay, so if this dot head means we are trying to access this head using this reference variable, we are accessing the instance of variable. So this head is equal to null. Yes, in the first, if you see even our diagram also, this head is still have the value null. So of course condition will be true. After executing this, it will go inside the if block, and here if you see, now inside this head we are assigning some value. What is that value? Whatever the address, basically we know this node is the reference variable, so this reference variable will be holding the address. Now in this line what we are saying, whatever the address that is present inside node, in our example in node 2000 memory address is present, so that 2000 should be assigned to this head, this dot head. Okay, so you might have understood means the value of head will be overridden, and now instead of having null, it will have value 2000. and this change basically is happening because of this line. Okay, because we are saying whatever the value present in the node reference variable, that should assign to head, and so we are assigning here. Now head is having the address of 2000, means head will also start pointing to the object which is having 2000 memory address, and we can clearly see that b is the object which is having 2000 memory address. Okay, so now if I draw the diagram something like this, I can draw, means कि this head is now also pointing to B object. Okay, this is what will happen on the execution of this, and since if block already executed, so else block will be escaped. Okay, and here it will print the message. This is like, this is a placeholder which the value of node dot data, that is 56, got inserted, that is the message will appear. So if you see on the console, it is printing 56 inserted into the linked list. This message came. Now what happens also, like you saw in the last time, when this line will get executed, then only that message is getting printed. Also, once the execution of the method gets completed, all the locally, basically we all know guys, the method this will be executed in the stack memory. Okay, so these all local variable that was created will be removed from a stack once the method complete their execution. So after completing this, we can see control came to here. Okay, but in the background what will happen, what are all the local variable those were created, they will be removed from the stack. So here you can see this node is the reference variable which was created inside this add method. This data is also local reference variable, so these they will be removed. Okay, so currently data we didn't mention anywhere in our diagram, so you just assume that got removed. And this node is a tool, basically this one will be created in the heap memory, so we cannot have access to that, but this node is there in the stack, hence this node will be removed. Okay, so if you see in our diagram, here is the node, and after execution of completion of the execution, this will be removed, so we can erase that. So here we are erasing, and this is how basically our linked list will look like after execution of the very first element. So you can see now we have one head, and a head will be pointing to the first object, that is nothing but B. And this is what I was telling you theoretically, like you can say head is pointing to first object, and in first object we have the data. Similarly here head is pointing to first object, that is B object, and inside B we have data 56, and next is still null, means this one is not pointing to any other object. Now if we go further, let's add 30 also. Okay, so when we execute this time, the value of data is 30, means again we are calling the add method, so again this method will be loaded into a stack memory. Okay, and after adding this one into the stack, all the variable that we are creating, that will be created in the stack. So again one object with node will be created. So here if I show you, constructor is getting executed, and on execution of constructor, basically object gets created, and then when object will be created, automatically the data will again be initialized, and this time the data is 30. So if I draw again the diagram, so here one more object of type node will be created, and inside this we will have two sections. The first one will be data set to 30. So data will be 30, and next will still be null, because even in this object also, if I, so even in this also you see we are not initializing the value of next. So data is value having 30, and next is still having the value null. So this is what we draw, and automatically if object gets created, they will definitely have some address. Let's take some random example of address, that is 3000. Okay, and we can, for the sake of simplicity, we can name also. So name is not there in the computer, in real computer. This name ABC object we are giving for our simplicity purpose, nothing else. So this object will be created, and once this object gets created, this is what basically object will get created on the right side of the execution. Means whatever the expression that is written in the right side, once it will get executed, then only object will get created. Now after creating the object, it will return memory address. So 3000 basically will be returned, and that 3000 will be stored to this local reference variable node. Okay, so again the node reference variable will be created, and which will have the value 3000. If I draw the diagram, this node will be pointing to C. So this is what we can say, and that will happen on the execution of this line. Now if we go, so we this time we are checking if this dot head is equal to null. So this dot head means the head which is present inside this class, current class. So current class means linked list. Okay, so head reference variable of linked list object, in our example that is nothing but a object, is having null. You check here, you can see, do we have null inside the head? No, we have now some memory address. In our example, we have 2000 memory address. Okay, so definitely this in our example is 2000 and is equal to null. No, this condition will be false. It will go inside the else block. Okay, and now here what we are doing, like again one reference variable is getting created. A variable creation means we are giving the name of the variable as well as their type. So temp variable will be created, and what value we are assigning to temp, whatever the value that we have inside the head reference variable, the same value we are putting inside the temp also. Okay, so if you see in our example, the head is having value 2000. Okay, so that 2000 will be assigned to temp also. So in our example, let's create one temp reference variable, or here I will say temp also will have the value whatever is inside the head. Now you might have already understood what is that. Ki like if head is having 2000 address, it means ki head is pointing to the object which is having 2000 address. Likewise, temp will also start pointing to the object which is having 2000 memory address, and which is nothing but our B object. Yes, you understood it right. Like now temp will also start pointing to B object only. Okay, so temp is also one more reference variable got created to point the B object. Okay, so now B object will have two reference variable. One is head, another one is temp. Basically, this temporary variable we have created to trace, to traverse. Basically, we will be traveling, because if a new node is created, that should be added in the last. For that purpose, we have created a temp reference variable. Okay, now let's go further. And if you say while temp dot next means keep, please you can read it something like keep go to the object which is being pointed by temp. Okay, so temp is pointing to B object, means we can say here go to the B object, and in the B object read the property next, whatever the value present inside the next variable, which is present inside which object, the object which is being pointed by temp reference variable. And you see temp is pointing to B object, means the next present in the B object. So you can see next variable present in the B object is having null. Okay, so we will get this expression evaluated to null. Okay, now our condition is null is not equal to null, condition will be false, right? Because this is also null and this is also null, so null is equal to null, it's not like not equal to null. So since we are saying null is not equal to null, condition will be false. Control will jump to this line 22 that you can see. Okay, we are tracing the also code, so make sure you are getting it properly. Now, here what we are doing, again, whatever the value that is present inside the node reference variable, that we are assigning to next reference variable. Okay, which next? If you see here, we have multiple next. We have next reference variable inside C object also, and inside B object. So this confusion you can resolve by identifying the reference variable. Temp reference variable means you have to identify temp reference variable is pointing to which object. So currently if you see a temp is pointing to b object, it means next variable of b object should have a value that is present inside the node. So node will have value 3000. So same 3000 will be assigned to next of which object? B object, because currently temp is pointing to B object. Okay. So what I can do, the null value will be overridden here and the new value will be 3000. So this 3000 will be stored, and if I draw the diagram, yes, this next reference variable has the address of C object now. Okay, so I can draw diagram like this. We can say yes, this object also means this C next variable is pointing to C object. Okay, this is more. I will erase. Yep. So this next pointing to C object, and this is what basically will happen. After that it will print the message. This is a placeholder and the data that we are inserting is 30. Okay, so 30 inserted into the linked list, and now this line will execute. I'm having some issues, that's why it is not executing. So but still I will explain you. After executing this line it will print the message. Okay, because of some reason I'm having the issues with my system. So this line will execute, and you might have already understood. You see, once this line will execute, it means, or this add method has successfully completed their execution. Okay, if it has completed their execution already, means कि now they will be removed from a stack, will be unloaded from a stack. In that case, all the locally created variable that we created inside this one, that will also be removed from a stack memory. So this data, which is again a local variable, will be removed. This node will be removed. Along with that, this node temp reference variable which we created. So what is local variable? Local variable means all the variable that we are creating within the method. Okay, those they will be treated as a local variable. So this node, this temp. Okay, so these two and the data, this is also local variable, but we are not considering anywhere in our diagram, but you assume that will also be removed. So node and item basically will be removed from a stack, so that we have to remove from here also. Okay, so node I will remove, I will erase. Okay, along with that, temp is also, you see, temp was also created within this method, so we will remove temp also. I will erase. Yeah, so now you can see this is how link list looks like after having two element in that. Means now you have the two node, B is the node, C is the node. So in B object data is 56, and the next reference variable is holding the address of next object, that is C object. You can see now. Okay, so this diagram, this arrow I am drawing for our understanding purpose, but now you understood कि since next of B object is holding 3000, which is nothing but the address of C object. So this next is pointing to C object. Okay, and then still our code will be adding for 70. Okay, so I will put breakpoint here this time because we have already traced till 30. So one more time I will run. Okay, and let's go with 70. So data that we are passing is 70. Then again, as usual, we are creating the object of node, and we have already seen like data will be initialized to 70, and next will remain their default value, that is null. Okay, so this is what basically will be happening. Of course, one more object will be created. Okay, since this is of type node, they will have the two variable. One will be the data, so data will be 70, and as usual, next will have value null. So this next. will have value null, and of course they will have some memory address also, means every object will have some address. And let's put it some name also, so we can say this is the d object. And then when object gets created, what happens after creating the object, it will return address also, and that address will be stored inside a local variable called node. So this node also will be created somewhere, we can say here, and it will be holding the object, address of newly created object, that is d object. So 4000 will be stored inside that. If I draw diagram, we can say this node currently will be pointing to d object. Okay, this is the arrow. And then again this dot head is equal to null, the head variable that is present in the current class, because this will always be pointing to the current class, which is nothing but, in this you can see, add, for add method current class is linked list. So head variable present in the current class is still having null. You can check here and you can find no, head is having 2000, means address of first object, that is b object. Okay, so this condition is not null, it is having some value. So this condition will be false. Control will again go to else block. Okay, and here what we are doing, again we are creating one more local reference variable temp, inside which we will be storing the address of head, means whatever the reference variable is holding the address, same address inside temp also will be stored. So currently you see head is having 2000, so temp will also have 2000 only. So temp is equal to 2000. Okay, if I draw the diagram, so temp will start pointing to b object only. Okay, because a temp is also having the address of b object only. This is what will happen. And now while, so this while will keep executing for traversing purpose, so that in the last we can reach out to the last element of the linked list, and there we can add the newly created or node. Okay, so now temp dot next, which next, again we have multiple next. Please avoid confusion. You have to identify temp, means always you try to identify temp is pointing to which object. Once you are able to identify, you will never get confused. Okay, so currently if you see temp is pointing to b object, it means next variable present inside b object is null or not, you go and check. So next variable of which object, one that is pointed by temp, and temp is pointing to b object. So next of b object has none null value, other than null it has some value 3000 in our example. Okay, so definitely this one is other than null, so is not equal to null, condition will be true, because this time next is having some value. Okay, it is not null, so this value is not equal to null, condition became true. It will go inside the while block. And here if you see, what are we doing, we are assigning some value to temp. What value? So temp dot next, the next variable, whatever the value that we have inside the next variable, present inside which object, temp object, or the object which is being pointed by temp. Temp is pointing to b object, means next variable of b object has some value 3000, and that 3000 should be stored to temp. Okay, so now the value of temp will be overridden, and you might have understood the new value will be 3000. And this will happen because of this line. Okay, so now if you see, temp has 3000, and definitely this 3000 is not the address of b object. B has address 2000, so this arrow will be removed. Okay, temp is no longer pointing to b object, rather temp will be start pointing to c object. Okay, so yes, temp has the address of C object. So temp started pointing to C object. And then control will go next. Again, it will check while. So you can see now using temp, we are traversing. Initially, temp was pointing to B object, but B was not the last element. So we are checking. We now temp is pointing to C element. We are traversing. We moved from B object to C object now. Okay, So while temp dot next, again same question. What is this next? So next we have with multiple object. B also have next, C also have next, D also have next. My question is again same. How will you identify? So you have to identify the temp. So identify कि temp is now pointing to which object. If you see temp have started pointing to C object means next variable of C object. This is how we can read. So next variable present inside C object because temp is pointing to C object. So check whether this next of C object is null or not. If you see the next of C object is having null, okay. So this expression this time will be evaluated to null. Now null is not equal to null. Condition this time became false. Okay. So it will escape the while block and it will come here where you see temp dot next is equal to node means whatever the value present in the node reference variable that should assign to next. Obvious question is who's next? The one which is being pointed by the temp. Again temp is pointing to C object only. Okay, means next of C object. So next of C object should have what value? The exactly same value which is present inside the node. Okay, so you see node is having 4000. This 4000 should be in is assigned to this next also. So this null will be overridden, and you can guess now this null will have nothing but 4000. Okay, and if I draw the diagram you might have understood this next will start pointing to D object. Okay, so this is how basically it will work, and then it will print the message ki 70 inserted into the link list, and then it will come here. So now since this is the closing of this one, you might have understood again this got closed, this got completed their execution. So it's time to unload this method. Before unloading, all the locally created variable will be removed. So data, node, and temp all will be removed. Data already we are not considering. So node and temp in our diagram also needs to be removed. So node and temp I will erase. And this temp also will be removed because the add method has completed their execution. Yep. So this is what basically will happen, and now 70 also added successfully. So after adding these three methods, these three values, this is how our linked list will look like. Okay, where the first object head will be pointing to the B. This is head always will be pointing to the first node only, that is B object. Then B is pointing to C, C is pointing to D. This is called linked list where every node is pointing to the next node of the linked list, and the one which is not pointing to any other node, which is nothing but D, you can see their address is null. Next it means the address of next node is null. It means D should be treated as the last element of this linked list. So this is how linked list gets created. Quickly let's trace how display will be working for this. Okay, so we can go, and now we want to display all element those are present inside this method. Okay, this linked list. So display method, here you can see what we are doing inside this. Again we are creating one reference variable temp, and in this temp what value we are assigning? The address of head. So this head is having 2000. So here again what will happen? Temp variable will be created and they will have address 2000. Okay, and we are so we can say this temp will again start pointing to 2000. We have to traverse. So we will move, we will keep moving this temp. First time it will point to first object, then second object, then third object, and so on. We cannot temper the value of head directly. The reason is, if we will change the address to 3000, by that time the address 2000 will be removed from this one, and then there will be no reference variable which will be pointing to b object, so you might lose the data. That's why we are not touching head value. Rather, every time we are creating a new reference variable. So temp is pointing to this one. Actually, this is mandatory that every object must have at least one reference variable. So head will always be pointing to the first node, and we should not modify the value of head, because if you will modify, if you will put the value of c object, that is 3000, inside this head, then you can see his head will start pointing to c. Means, if you forget this temp also, so neither head nor temp will be pointing to B. So B will be treated as orphan object. No one will be there. Garbage collector will remove this object. So you will lose the data. That is the reason you should not touch head. Rather, create the temporary reference variable. So we created here. Now what you can see inside the if block, temp is equal to null. If you see, do we have null inside a temp? No, we have 2000. So condition became false. This is to check whether linked list is empty or not, but this condition is false, so it means our linked list is not empty. Definitely we have some value in our linked list that you can see. Now it will go inside the while, because we will keep traversing. So temp is not equal to null. Of course, condition is true. Temp is having 2000. So temp is not equal to null. It will go inside this, and here it will, it is trying to print. Console.write will print the message on the console window. So what value we are printing? Temp dot data. Question is which data. Again, we have multiple data. We have data inside b, we have data inside c, we have data inside d. If to answer this, we have to identify the reference variable. So you check this temp reference variable currently pointing to which object? B object. So data of B object will be only printing here. Even if I hover, you can see it is showing 56. Okay, because temp will be pointing to b object, and that's why the data inside the b object we have 56 value, and hence 56 will be printed. Okay, if I show you, you can see, we can see here 56 got printed as the first element. Now what we are doing, temp should start pointing to the next node. Okay, so for that we are saying temp dot next, means whatever the address present inside the next reference variable. Which next reference variable? The object which is being pointed by temp. So temp is pointing to b object. You can see temp is pointing to b object, means next of b object, which is having 3000. Okay, so this expression will evaluate to, in our example, as 3000. So this 3000 will assign to this temp. Okay, in our example, so this temp now will have value 3000. So it will be overridden here, and the new value will be 3000. Okay, so this arrow will be removed. Okay, and this temp will start pointing to the new object, that is called nothing but c object, because temp is holding the address of c object. Okay, so temp started pointing to c object, and then again it will go to while. Here temp is not equal to null. You see, still temp is having 3000 as per our example. So yes, this condition is still true. Okay, so it will go inside that, and again it will print the data. Question is which data? The one which is being pointed by temp reference variable. Temp is currently pointing to C, means data of C object, which is having nothing but 30. Okay, so if I hover, you see the value 30 is showing. Okay, so this 30 will be printed, and then again, okay, that got disappear, but no problem, we will still trace by ourselves. Okay, because debugger disappear. Okay, this is the issue with my Visual Studio. So now temp is not dot next. What will happen? Ki temp dot next means next variable whatever the value present in the next of temp object, or you can say reference variable. So temp is pointing to C object. So next of C object, that is 4000. Okay. So this 4000 will assign to temp. Okay. So now temp will have 4000. If I, this value will be basically overridden and the new value will be 4000 here. So this one I need to erase this diagram, and you might have understood this time my diagram will be for D object. Okay, because temp is holding the address of D object. Okay, 4000, and you see 4000 is nothing but address of D object. So what will happen again? Control, if control would be there, it could come here. Okay, and it will check if temp is not equal to null. You see, temp still have 4000, so condition will be true. It will come inside this and temp dot data. So what is the data present in the temp object? Temp means temp is pointing to D object. So data of D object is having value 70. It means here, it will print 70 this time. Okay. And then after printing the 70, it will again temp dot next, means next of temp. So temp is currently pointing to D object, means next of D object, which is nothing but null. Okay, so this time this expression will evaluate to null, and null will be assigned to temp. So you might have understood that now the new value of temp will be null. Okay, so this is null, which represents it is not pointing to any object. Okay, so this arrow will be, removed. I need to erase this array, I mean arrow. Okay, it is no longer pointing. Yeah, and temp is null this time. Again, this will trace will come here while temp is not equal to null. If you see, temp is this time having null. So condition will be temp is equal to null. This temp is not equal to null, condition became false. Okay, because temp is also null and this one is also null. So they are equal to each other. It's not like they are not, but we are checking condition not equal. So condition became false. It will exit, and before exit, whatever the, before that, this display will be unloaded from stack, and so before that all locally created variable will be destroyed. So this temp was created, it will be removed. So this temp will be removed from the stack, and by that time it will print the entire value that you saw in our tracing. So here in between only, in middle only, our debugger was stopped. So I will run at one go. Okay, I will not see breakpoint, I will remove, I will run, and you can see output we are getting 56, 30, and 70. So this is how basically linked list work. This is how you saw, like we can add the record and we can display the record. Okay, so this way we can create our own linked list.